One moment, the ocean is calm. The next, a wall of water comes crashing in, unstoppable, unforgiving, a tsunami. But how can a wave that starts deep underwater end up wiping out entire cities? What invisible force triggers it? And could it happen again? Today, we are diving deep into the science of how tsunamis form, what causes them, and why they're far more complex and terrifying than most people think. By the end of this video, you'll never look at the ocean the same way again. A tsunami is not just a big wave, it's a series of waves caused by a massive disturbance in the ocean. And like normal waves, which are caused by wind and only affect the surface, tsunamis move the entire column of water, from top to bottom. They travel incredibly fast, up to 800 kilometers per hour or 500 miles per hour in deep water, and can cross entire oceans in a matter of hours. But in open water, you might not even notice them. The danger comes when they reach the coastline. That's when they rise, slow down, and turn into towering walls of destruction. So what causes a tsunami? The most common cause is an underwater earthquake, especially in areas with subduction zones, where one tectonic plate slides beneath another. This sudden movement displaces a huge amount of water, triggering the wave. But that's not all. Tsunamis can also be caused by volcanic eruptions, like Krakatoa in 1883, underwater landslides, glacial collapses, even meteorite impacts, yes, like the one that wiped out the dinosaurs. All these events have one thing in common: they move a lot of water very quickly. That's what unleashes a tsunami. Once triggered, a tsunami radiates outwards like ripples from a stone thrown in a pond, only these ripples are traveling at jetliner speeds. In deep water, the wave height may be just a few centimeters, barely noticeable. But as the tsunami nears shallow coastal waters, something dramatic happens. The wave slows down, it compresses, and its height increases, sometimes to over 30 meters or 100 feet. This is known as wave shoaling. And it's what makes tsunamis so devastating. Even more chilling, before the wave hits, the shoreline often pulls back, exposing the ocean floor. That's the ocean taking a deep breath before unleashing fury. Two of the deadliest tsunamis in history remind us how dangerous these waves are. 2004, Indian Ocean Tsunami, caused by a magnitude 9.1 earthquake, over 230,000 lives lost across 14 countries. Waves reached up to 30 meters. And 2011 Tohoku Tsunami, Japan, triggered by a 9.0 quake, caused a nuclear meltdown at Fukushima. Over 18,000 people killed or missing. Damage costs over $200 billion. These weren't just natural disasters, they were human catastrophes, reshaping coastlines, lives, and history. While we can't predict earthquakes yet, we can detect them immediately. Tsunami warning systems use seismic sensors and deep ocean buoys to detect sea level changes in real time. If a tsunami is detected, warnings go out via sirens, radio and TV, text alerts, emergency apps. But in many parts of the world, especially poorer regions, these systems are still underdeveloped. Preparedness can mean the difference between life and death. Tsunamis are rare, but when they strike, they leave scars that last for generations. Understanding how they form is the first step to staying safe and respecting the raw power of our planet. If you found this video valuable, give it a thumbs up, hit subscribe, and let us know in the comments, did you know tsunamis could move that fast? Stay curious, stay safe, and we'll see you in the next one.